And in question 2, it is suggested that the following functions of v, which in question A, f(v) is equals to e times minus v, and b, f(v) is equals to sine times 2v divided by v times 2, and c, f(v) is equals to 1 when v is smaller or equal to alpha, or v is bigger or equal to minus alpha, and f(v) equals to 0 when v is bigger than alpha or v is smaller than minus alpha. And these functions of v may represent an autocorrelation function of WSS stochastic process by citing v is equals to epsilon, or a spectral density function by citing v is equals to omega or both, and which functions f(v) may represent either or both, and explain your answers. We know that if R epsilon is an autocorrelation function of a real WSS stochastic process xt, then it is even and R epsilon is smaller or equal to R0, and its Fourier transform is non-negative. If S omega is a power spectrum of a WSS process xt, then it is non-negative. So in the function of v in question A, the f(v) is equals to e minus the absolute value of v. So it may represent an autocorrelation function because e minus the absolute value of v is even, and e minus absolute value of v is smaller than e minus 0, and e minus absolute value of v can transfer to the to alpha divided by r is divided by alpha squared plus omega squared, and which is non-negative. And 2, it may represent a power spectrum also because e minus absolute value of omega is bigger or equal to 0. And in the functions B, f(v) is equals to sine square v divided by v squared, and it may represent an autocorrelation function because sine square epsilon divided by epsilon fun is epsilon square is even, and sine square epsilon divided by epsilon square is smaller or equal to the limit epsilon to 0, sine square epsilon divided by epsilon square, and which equals to 1. So it is non-negative. And 2, it may represent a power spectrum also because that sine square omega divided by omega square is bigger or equal to 0. And in the function C, the f(v) is equals to 1 when the absolute value of v is smaller or equal to alpha, and f(v) equals to 0 when the absolute value of v is bigger than alpha. First, it cannot represent an autocorrelation function because its Fourier transform is 2 times sine alpha omega divided by omega, which is not non-negative. And second, it may represent a power spectrum also because f omega is bigger or equal to 0.